So this is where this relationship is coming from. Hello and welcome to my YouTube channel. My name is Deriving. If it is your first time coming across my videos, kindly tap that subscribe button and turn on your notification bell so that you can be notified every time I upload a video. So in this tutorial we are going to try to answer this question where you are told to use the identity sin squared theta plus cos squared theta equals 1 to show that tan squared theta over sin squared theta equals sin squared theta over cos squared theta plus 1. So before we deal with this question, we need first of all to show how to derive this relationship sin squared theta plus cos squared theta equals 1. I know that most of the course book that we usually use unit circle to derive this relationship, but in this tutorial I'm going to use something very different and very simple. So I'm going to use the right angled triangle. If you consider triangle, right angled triangle, A, B, C, we say that using the Pythagoras theorem, we say that AC squared equals AB squared plus BC squared. Now if we divide both sides of the equation by AC squared, so I want to hurry up in this area so that this video will be not too long. So when we divide by AC squared, we shall have 1 equals AB squared over AC squared plus BC squared over AC squared. Now, when we use the SOHCAHTOA now, the relationship of SOHCAHTOA, so we know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Now, if you consider this angle theta, then AB is the opposite side and BC is the adjacent side, AC is the hypotenuse side. Now, when we look at what we have here, AB is opposite. So if we say that AB is opposite over AC, which is now hypotenuse, and this is square. This means that when we have SOHCAHTOA, where we use opposite over hypotenuse, this relationship refers to sine theta now squared. If we consider this other part, BC over AC squared, BC is adjacent over AC hypotenuse. Now squared is the same as, when we come here we shall have adjacent over hypotenuse, so this is the same as cos theta but now squared. So if that is the case, then this part 1 equals ABC squared, AC squared plus BC squared over AC squared, then it can be written in another way, substituting this with the sine theta squared and this with cos theta squared. So therefore we shall have sine squared theta plus cos squared theta equals 1. And this is the identity we are talking about. Remember that sine theta over cos theta is equivalent to tan theta. I I have showed this in the tutorial that I have done in regard to trigonometry 1 and 2. So I'm not going to explain much on this. So these two relationships here are going to help us to solve that equation. And with this in mind, then acquiring these formats is going to be very easy. So the first step is to ensure to substitute this relationship in the equation. But when you look at it, there is no direct substitution. We don't have 1 here, so that we can substitute 1 with sine square and theta plus cos square and theta. There is no other way we can directly substitute this relationship to either of the side of this equation. So for the first step, if there is no direct substitution, then we are encouraged to make sure that in the equation we only have sine and cosine. But when we look at this equation that we have here, we can see tan squared. So we don't want to see tan squared theta. So what we are going to do, we are going to use this relationship of tan theta equals sine theta over cos theta to substitute this one so that it can be in terms of sine and cosine. So because what we have here is tan squared, we are going to square sine squared theta over cos squared theta. So without much ado, because I don't want this video to be too long, I am going to start by doing that. So the first step is to ensure that in the equation, what we have is only sine and cosine. So we have now substituting tan theta squared equals sine squared theta over cos squared theta. We will have sine squared theta over cos squared theta. This says division, so we divide by sine squared theta. So we do the normal division. We shall have sine squared theta over cos squared theta times the reciprocal of that 1 over sine squared theta. So what we have now, because this looks like this, then we cancel by sine squared theta, 1 by sine squared theta. So we are left with 1 times 1 is 1 all over cos squared theta times 1 equals cos squared theta. Now after doing that, don't go to another step before you can look at the right hand side that you want it to be identical with the left hand side. And now because we have simplified our left hand side to 1 over cos squared theta, we want to ask ourselves, how can we make this one look like this? If you look at it keenly, then it means we can directly substitute 1 with sine squared theta plus cos squared theta. Remember we said that 1 is equivalent to sine squared theta plus cos squared theta. Now substituting, we have, where we have 1, we substitute with sine squared theta plus cos squared theta all over cos squared theta. Cos squared theta. Now we are done. So looking at cos squared theta and the numerator sine squared theta plus cos squared theta, then it means that cos squared theta is the common denominator. And since it's the common denominator, then we can split it. Now splitting what we have sine squared theta all over cos squared theta. Remember cos squared theta is common denominator, and therefore we add cos squared theta over cos squared theta. We are going somewhere. You can see we are going somewhere because cos squared theta over cos squared theta will cancel into 1. And since it will cancel into 1, we shall have sine squared theta over cos given equation, then it means that tan squared theta over sin squared theta is equivalent to sin squared theta over cos squared theta. And by so doing, then you have proved that the left hand side and the right hand side are equal when you're using this relationship. And by doing so, you score your full 4 on maths. Maybe we can look at another example to make everything clear. In this case, I have decided to take the left hand side. So again, if we remember that tan squared theta is equivalent to sin squared theta over cos squared theta, and now substituting in the numerator, what do we have? Instead of having tan squared plus 1, now we have sin squared theta over cos squared theta plus 1. Now we find the LCM of this one, of cos squared theta and 1, because 1 over 1 is 1. So LCM shall be cos squared theta. Now this means that now cos squared theta, this will go to this into 1, then 1 times sin squared, we shall have sin squared theta plus cos squared theta divided by 1 is cos squared theta times 1 is cos squared theta. This is normal way of operating numerals. So now that we have this, don't forget that we say that sin squared theta plus cos squared theta is equivalent to 1. So the whole of this one now becomes 1. Now substituting, we shall have 1 over cos squared theta. So this becomes cos squared theta. Now the denominator is to combine the numerator and denominator. So then we divide by tan squared theta. If we carry all this here, we shall have 1 over cos squared theta. Now we multiply. Remember, this is division, so we are going to multiply. Multiply by 1 over tan squared theta. But remember, we said for you to successfully deal with such questions, we need to ensure that we don't want anything that is not cos and that is not sine. So you know that, but tan squared theta is equivalent to sine squared theta over cos squared theta. So we substitute it here. We shall have 1 over cos squared theta times 1 over tan squared theta or sine squared theta over cos squared theta is the same as cos squared theta over sine squared theta. So this goes with this, and we are left with 1 over sine squared theta. But sine squared theta is equivalent, if we use the relationship, is equivalent to 1 minus cos squared theta. This is because we said that sine squared theta plus cos squared theta is 1. So if we take this to the other side, we shall have sine squared theta equivalent to 1 minus cos squared theta. So this is where this relationship is coming from. And if that is the case, then our 1 over sine squared theta will be equivalent to 1 over 1 minus cos squared theta. And this looks exactly like this. It proves that now this left hand side of the equation is equivalent to the right hand side of the equation. This marks the end of our tutorial. Kindly share widely. Bye.